Okay, hey folks, Mark Locklear here with a screencast on Chapter 5, and this is how to work with I/O streams and files. So up to this point, we've been doing everything inside the console. So we have been working with I/O streams, right? I/O just stands for input, output, and up to this point, the input has been coming from the keyboard, the user typing on the keyboard, and then we may manipulate that data or do something with it, and then the output has simply been the sort of screen, the command line window where you see output. So in this chapter, what we're going to add to that is this idea of input output streams to a file. But again, more broadly, this idea of streams is something that's very common in software development. And again, this stream, there can be multiple streams of input from different sources, and then there can be multiple streams of output. And input can be things like, as I said, the getting input from the keyboard. And input could also be some external source like an API or some other data source. Just think about, for example, the weather data center that's downtown here in Asheville. They have terabytes and terabytes of data that come in every day from satellites, from weather stations scattered across the US and around the world. So all different kinds of input streams coming from different places. So generally when we talk about streams, it's this bigger concept. It's not just this idea of either a keyboard or a file. You could be getting input from all kinds of places, and you can be outputting to all kinds of places. Again, this chapter we're going to talk about outputting to not only to the screen, and we'll talk about some formatting things, but you'll also be outputting or writing to a file. But again, think broader than that. You could be running a process and outputting to some other data source. You could be outputting to a local file that is again is going to serve as output or input for some other system, some other place. So we're sort of in the age now where data is flying all over the place. And again, when we talk about input and output streams, that data is being input from many, many sources, and it's oftentimes being output to many sources. So I'm going to share my desktop here. I think what I'm going to do for this screencast, normally I'll do one of the exercises. I think I'm just going to, and I'm going to share this code inside the Moodle shell. So if you want to look at it, you can look at it there. But I'm just going to sort of walk through a handful of some coding examples of some of the various concepts in the chapter. So the first one we're going to look at is is input streams. Okay, this should look somewhat familiar. The CN and COut statements, but I'm going to also add this CN ignore. We're going to look at that last. First, we'll sort of see what the output is without these CN ignore statements that are still commented. Then I want to show you sort of the purpose that they serve. So if I run this now. So this works fine if I play nice and I do what I'm supposed to do, right? I'm going to put in an integer, a double, single character, and then the word test. And then this is the output, and that's correct, right? That's what I inputted. But let's say I do something a little funky and I fat finger something, or I do something like this. Well, the program just falls right through, right? So we've got a data validation chapter. We'll talk about data validation later in the book, but when we talk about data validation, we're really sort of at the heart of it is protecting the user from themselves. It can also be called idiot proofing your programs, but essentially you want to account for any errors that the user might make. Okay, people do all kinds of things with software, and it's up to you to make sure that you have to save them from themselves many times. And so we do that by checking the input that they're entering in the console, and also doing things that give us the best chance at getting the input that we want from them. So these CN ignore statements help you do that. And so basically what they do is they're going to grab the first piece of data that the user inputs, and then they're going to throw everything else away. And we'll see how that works. Let's test both test cases though. Let's test first off the correct, that if they do the correct thing and do everything exactly as they're supposed to, let's make sure that works. So we'll type in test. Okay, that looks good. I like that. So let's do something similar to what we did last time. And then if I type test, Now, so notice it didn't blow the program up. And in fact, as long as, now this is incumbent upon them entering the right data types at the beginning, but notice, and in fact here I can do something like that. Yeah, and you know, even though I entered more than a single character, we'll see on the output that it's only going to output that first character, T. And then if I do something like test, something like that, okay? So notice that even though I entered what I like to call malformed data, or you know, some invalid input, it's still got all the correct values and printed them out here. And just so you understand, here's the C out statement. Now again, this is incumbent, and we'll see. I think they look at later in the chapter, looking at type checking to make sure the user enters the correct type. But notice, even though I've entered data that I shouldn't have, it throws that away. So that's what this see and ignore statement does. See and ignore says that, hey, we're going to only grab the first piece of data that's input. So just as an example, on this first part, I put in the number 2, and then I put the string letter test in. It's going to grab the first piece of data that I input, which is 2, and then from here on out, it's going to throw the rest of that away. That's what this. That's what the ignore part is, and then the streamline, stream size max up to the carriage return. It basically looks after the valid piece of data is entered. Anything after that, up to when the user hits return on the keyboard, it's going to throw the rest of that data away. So that's that just gives you a sense of how that works. And again, the idea is just sort of trying to make the interface as foolproof as possible, so the user doesn't shoot themselves in the foot. Okay. All right, let's look at some output streams and sort of modifying the way output streams look. So we'll just take this sort of one column at a time. So notice I've got this, and I think you've got an assignment in the book here, the trips.txt. I know you're doing it where you want things in nice columns on the screen. And lots of times in console type applications that are text-based, you're going to see this nice formatting that's on the screen or in the output. And so, you know, if we just do something like this, you can imagine what the output's going to look like. It's going to be bunched up. So notice this is it here. It's bunched up together. It runs right up against each other. There's no spaces between anything, and nothing's lined up. So that's not a very good experience, right? So let's look at, if we look at something that looks a little cleaner, we're going to put some tab spaces. So this is what this \T does. We're going to put some tab separators in between data, and let's see how that looks. Okay, so this is a little better. Column 1 and column 2 are sort of nice, but notice that this first piece of data, second piece of data text is long enough that, you know, tab is only giving you about 10 spaces, I think is what it is. So because that text is bigger than 10 spaces, doesn't really help us out much, right? That data, at least in the second part, still looks fairly bunched up. And then finally, let's do, so notice here we're using the set W method, that's set width. So we're setting the width of each of these columns to 25. And then at the top for column 1 and 2, we're going to actually left justify those. And let's see how that looks. All right, so much better here, right? Again, setting the width of these columns to 25, and that is like from this point up to right there is 25. So that's what that set width does. And then the left, actually making this call to left, actually left justifies the data so that it's sort of pushed up against the left. Now you could also right justify that if you wanted to move it the other way. But anyway, those are some those are a couple of things you can do to format data and when it's output on the screen. Okay, and then finally, let's look at some file streams where we're going to actually save data to a file. So notice off to the side, I've got this names.txt file. This is inside my, let me pull up my chapter 5 folder just so you can see. This is going to be in different places. So you can see here, if I click, it actually shows up here, but it doesn't show up inside, at least for Xcode on Mac. You're not able to see it inside the editor. and it's going to be a little bit different for Visual Studio folks too. And you may have to jump through some hoops. The book, I think, goes into detail about creating a file and having access to it. So I won't get into the weeds with that, but let me know if you have questions about it. But either way, we can see this is the content of the names.txt, which is not anything there now. So if I run this, I'm going to get this message. Mac always throws this up on asking for access to the file system. And then if I go over here, notice I've written the text to Mark Locklear to that file. So I've simply created an OF stream, in this case called output file. I could call this anything I want. Output files are a pretty good name for it though. And then I actually run this open method that actually opens or creates the names.txt file. Now in this case it was already there, but if it wasn't there, it would I think pretty sure it would create it for you. Then I'm outputting this text to Mark Locklear. Again, I could put anything I want in here, but it's just going to send that text to that file. And then I'm finally going to close the file at the end. This is an important part. You always see this, and this is ubiquitous across programming languages. Generally, when we're talking about file streams, you want to always open and close those streams. That's sort of a neat, tidy way to access input and output streams. You always sort of want to close or sort of officially shut down a stream once you're done with it. So that's what that file, and then in this case the close method does. Now if I run this again each time, it's not going to append, it's not going to keep adding Mark Locklear. Basically it's just going to when it opens the file, essentially it's creating a new file each time. And even so, even though I just ran that again, notice I've still just got Mark Locklear there. So you've got append, and you've got a couple other methods there. I'll show you an example of the append method. So in this case, notice I'm calling this same open method, but then notice I'm passing an extra option to the open method here. And this is that iOS APP, which is the app stands for append. So now I'm opening the file, or I'm opening this file stream in append mode. So that means I'm going to, I'm not going to blow away what's already there. I'm only going to add to or append to the data that's already there. In this case, I'm going to put my daughter's name there, Faith. And so if I run this, I think I'll get a message that's going to ask for access to the desktop. I'm going to say okay. And then notice I go here and I've got Faith Locklear there also. So I've successfully appended to. Now, in fact, yeah, let's just, so we can sanity check this, let's comment out this, and yeah, let's comment out that. And I'll give you a second before I run this and think about what do you think this file is going to look like afterwards. Okay, think about that for a second. And now I'm going to go ahead and run this. And what it should do is append. So the existing data was already there, which was Mark Locklear and Faith Locklear. So I should have another line now, because I've ran this a third time, that has a second entry of Faith Locklear. So you see the last time I ran this, it appended this. And if I keep running this each time, I would run this now. Each time I would run this now, it would append Faith Locklear to it. So see, notice that shows up again there. Okay. Alrighty, I think that is all we'll discuss for now. Good luck, and if you have any questions, please let me know.